let's do some trig. So prove cosine of a minus b is equal to cosine of a cosine of b plus sine of a sine of b. So we're going to prove this difference identity that you will use in your trig class. So let's start. These are unit circles, by the way. So right here, let's call this, right here, let's call this point A. Point A is going to be 1, 0. 1, 0, yeah. And let's put it right here too. A, 1, 0. All right, that's 1, 0. So let's start with making an angle. Let's name this point, let's name it Y. And let's name this angle, let's name it B. Now let's draw another angle. This angle is going to be called, let's call it Z. And this angle right here, all of this, all of this, I'm trying not to like make it too confusing, but all of this from here to here to the angle that leads to point Z, we're gonna call that angle A. Okay, so this is angle A from the x-axis to this point, this line, that's angle A, and this little angle is angle B. So let's name this angle, just this angle from here to here, not including B, because this is A. This angle right here, where it's going to be called A minus B, angle A minus B. So let's put some, hold on a second, let me change my marker. All right, now that I have my black marker, let's name point Z, let's name its coordinates cosine of A, and then sine A, right? Sine A. So those are the coordinates for this point. Now let's do Y. What should Y be? Y should be, let's name it cos B, and then sine B. So that is what we should name this point right here. So now what I want us to do is I want us to bring this angle, this triangle that we just made, this triangle, now it's a triangle, all the way to point A. So let's flip this or turn this triangle all the way to point A, like that. We're going to close in on this angle B, so let's go ahead and do that right now. So point Y is pretty much going to become point A at this point, so it's going to be right here. So let me switch my marker again. I want a blue marker. You know, from now on I'm just going to write with the blue marker to stop from pausing. So let's go ahead and move our angle, our triangle, like this. Doesn't matter where you put it, just for the sake, it doesn't really matter where you put it. So now we have a new point. This is point A, so let's call that point, I don't know, B. Let's call that point B. And this will be cosine. What do you think it's going to be? A minus B, because we basically subtracted the B. So cosine A minus B. And then your y coordinate is going to be sine of A minus B. All right, so now we're going to go ahead and we're going to derive or prove this identity by using the distance formula. So the distance formula, I suggest you go look it up if you don't have it fresh in your memory, because I'm not really gonna go over it right now. It's just gonna make the video way too long, so go ahead and look it up. So the distance formula, we're gonna look at this. The distance from point Z to Y, isn't that the same distance? 'Cause all we did was just turn it. Isn't this the same distance as point A to B? Equals distance of point A to B. Is that not the same distance? It is. So we're going to use a distance formula to prove this identity. So let's go ahead and start off with distance z and y. Distance between point z and y. So the distance formula actually has a square root, but we can actually get rid of the square root by actually just squaring both sides of the formula. So let's just square both sides. That way we don't have to put the whole square root. So let's square this one. So this is equal to, what is your x value? X is cosine minus, that's your x2 minus x1, right? So it'll be cosine, let's put the parentheses, cosine cos A minus cos B minus cos B squared. I'm gonna have to square that, plus sine A minus sine B. Sine A minus sine B squared. So let's go ahead and square this. So we're just gonna FOIL it, or whatever it's called. So that is gonna give us cos 2a, I believe. I'm doing this from in my mind. Minus 2 cos, let's hope this actually works because I'm doing this in my mind, cos A minus cos B, and then plus cos B squared, cos 2b. That's a b, by the way. And let's go ahead and do this one. So this will actually be sine 2a minus 2 sine A, 2 sine A sine B plus sine 2b. Let's go ahead and combine this stuff. So we're gonna go ahead and combine it. Let's combine. You need to know the Pythagorean identities for this, by the way, so I forgot to mention. But I'm pretty sure you guys know at this point. We're gonna combine this one with this one. And we're gonna combine cos 2b with sine 2b. So combine this one and this one, what are you gonna get? You're gonna get 1. Plus, combine this one with this one, what are you gonna get? You're gonna get 1. Let's just write that as 2. 1 plus 1 is 2. 2 minus, you see here, if we add these together, this one, adding with that, they have a -2 in common. So let's go ahead and factor out the -2. So we're going to factor out the -2. So factor out the -2. Because both of these have a -2 in common. Just factor that thing out. So we're going to have a -2 and then parentheses. Cos A, cos B, plus, because now we have a plus sign because we factor out the negative. Sine A, sine B. Looking familiar already? Okay, so now we have that, right? Cos A, cos B, sine. All right, so now let's go ahead and move on and do this one. The distance of the distance of point A and then B. Again, we're going to do the square. We're going to square both sides of the distance formula so that way we can get rid of the square root and not have to deal with that. So that will be, let's see, what will it be? It'll be cos A minus B minus 1, right? So cos A minus B minus 1 squared. And then plus, what will it be? Sine A minus B minus 0. So let's just write And we're going to square it, right? We're going to square it using the distance formula. So let's just write sine squared a minus b. We're just squaring it using the distance formula, and we don't need to do the minus thing because that's a 0 anyways. We're subtracting nothing. So let's go ahead and FOIL this. I can't really do this in my mind, so let's go ahead and I'll be right back. I'm going to have to FOIL it. All right, if I did it correctly, it's going to be, when you FOIL this, you multiply this together, it's going to be cos 2a minus b minus 2 cosine a minus b plus 1. And then don't forget the plus sine squared a minus b. So let's combine this one and this one together. Pythagorean identities, what does it equal? It equals to 1. It equals to 1. But wait, we have a plus 1 here. Let's just add the 1 to the 1 that this thing equals, right? This equals to 1, and then we add the 1 right here. That's the 1. So it's going to give us 2 minus 2 cosine a minus b. All right. So now that we have these two pieces, this big one and this big one, just set them equal to each other. So let's set them equal to each other. So 2 minus 2 cosine of a minus b is equal to 2 minus 2. 2 minus 2 parentheses cosine of a cosine of b plus sine of a and then sine of b. Right? Yeah. So we're gonna subtract 2 from both sides. Cancel, this thing cancels. And then divide both sides by -2. So once we divide both sides by -2, guess what we have? We have cosine of a minus b is equal to cosine of a times cosine of b plus sine of a times sine of b. And look at that. We have proven our identity. And now you guys are ready to use this identity for like your trig stuff. So yeah, that's it. Now you're ready to use this identity.